Hi there! In this video I want to talk about how to assemble the Z80 Note kit. Now I'm going to be mailing these out soon. And I have done a video on this in the past, but in this video I want to specifically talk about how the kit itself will be assembled because it is going a little different. So it'll come like this. It'll be a piece of painter's tape across it and a bag of components, right? So let's just take a look. Oh yeah, and I need to sign each one. My signature sucks. What is it? 10, 1, 20? Gotta remember to do that actually. That's why there's that white piece there. So these components are just held in place by the tape. And the Z80 is in the socket, but the socket's not soldered. So I just did that so it's easier to ship. So in this video, I'm gonna show you basically what still needs to be soldered and how to get it running. You'll notice there's several components on it already. What we did, Jesse Robinson and I, we stuffed these enough that we could flash the bootloader onto the microcontroller. So this will act as an Arduino Leonardo. So it will come with this header already attached. This bus multiplexer is already attached because it's so close to that header, you know, you can't solder them out of order. There's the reset pin, which you shouldn't need after, you know, we've done this. The crystal power switch, and I also installed all the surface mount resistors. So there's no surface mount capacitors. So there's a few more you'll have to add, such as this one UF here, here, here. Okay, that's all of them. Yeah, so I just tried to make it as simple as possible. Now, you only need to install these two pull-ups if you're not using the screen. That's for the I2C bus. The screen itself has pull-ups on the I2C bus. That's why you don't need to use those unless you're not using the screen. All right, so let's, it's surface mount, so let's do everything low to high. Dump out my bag of parts. Now, since this video is somewhat faked, like all videos, not all the parts are here. I'm kind of doing this just to help myself as well. For instance, you don't see any of the 0.1 UF capacitors. All right, let's start with this port chip. So port 90. Now what that allows is for the Z80 to talk to the joystick and the buttons, right? And this is actually used as a switch, so the Atmel can also use the buttons and the switches. So basically they take turns. All right, so we need to find the 245 transceiver. Okay, there it is. So it's 74LS245. Okay. And now we see that there's the pin 1 indicator right there with an arrow in the circle. So that chip is going to go right there. Now, one of the motives behind the workshop was going to be talking about surface mount soldering. And even though some of the surface mount soldering has already been done ahead of time for you, there still will be some involved. I mean, I didn't want to make things even more difficult for people, making them having to flash their own bootloaders. So that's why I just did that ahead of time. Basically, I'll test some of it so there's less, since I'm not there in person to make sure it's working, there's less chance of error. Oh, there'll probably still be errors. So yeah, I'm just gonna... We actually pasted these with a stencil and put them in an oven. We could have done all the parts, but we thought we should leave something for the people to do. Also, laziness. Well, if everything's put together, it's not really a kit, is it? All right. And then if you have any rubbing alcohol left, if you've, managed to get some from the Para Road Warrior Militant Hordes, just take a Q-tip and some rubbing alcohol and you can clean up any extra flux. Or you can use flux remover as well. But, I don't know, rubbing alcohol works fine. I usually try to get like 90, 95%. So there's 2 RAM chips, each one is 32K, and they're these big obvious chips, so they're pretty, it's pretty obvious what they are. Shouldn't even need the magnifying glass. So I'm just gonna tin one side of it. tin one side and then position it precisely. Then wait for that to cool. There you go. And if you want to leave a comment below about how I'm not using flux, go ahead. I mean, I don't care, but you know, you're free to express that opinion. So we get one side locked down, then get the other side locked down. There we go, happy little clouds. Now remember, people think you have to go in and accurately solder everything for surface mount. That's just not true. I mean, even with like, you know, professional paste oven, you know, it's more about the surface tension of the solder. Well, I mean, they do have, the paste is separated. But yeah, just blob it on there. And then one thing I would suggest that you buy, if you're going to put this together, is some solder wick. It's going to be more useful with surface mount than like a desoldered iron. Yeah, just pull up the excess solder and you're good to go. See? You don't need to be a precise robot. You just need solder wick. And even if you don't have solder wick, you can just clean the tip of your iron. Make sure there's no solder on it, and you just kind of go whoop and pull it away. Clean it off that way. You'll note it says 64K SRAM, so that means static RAM, which is different than dynamic RAM. Dynamic RAM needs to be refreshed, else it will lose its contents. One of the big advantages of the Z80 was it had built-in refresh circuitry. So using the Z80 CPU in the early 80s allowed you to simplify your design. And we still use DRAM or dynamic RAM now because it's cheaper and you can have higher capacities because it's simpler. So, you know, in your computer, you know, your modern PC is still using DRAM because, you know, you have to refresh it, but in exchange you get much higher density. But in this case, just small amounts of static RAM, like 64K, it's totally affordable. And what you can do, at least with this device. Oh, I'm sorry. These, all right, these are the other two I/O expanders. It's a TCA 9534, right? And so pin 1 is there. The reason I'm using these I/O expanders is because I'm using like a AT, what is it? AT Mega 32UA, which is like the USB version of the 32.8. And I could have used like a AT Mega like 1280, and that would have given me plenty of I/O, and I wouldn't have needed to use these expanders. However, the 1280 wouldn't have been a very human surface mount friendly component, right? So what I opted to do was, instead of having a larger chip with more I/O that would have had a really fine pitch to it and been very difficult to solder, I opted to use a, you know, smaller chip with larger pins and then supplement that I/O with additional circuitry like the kind I'm attaching right now. Additional circuitry which also has larger pins. Like this is like, you know, these are like SOI 14s. This is like one of the largest surface mount pins you're really going to come across. Everything else is smaller. Same thing with the resistors. Those are all like 1208s, which is like one of the larger size of surface mount resistors. All right. Again, I'm just going to flood. So what this does is the Arduino uses these two I/O expanders to control the 16-bit data bus. So this CPU can basically access any of the RAM that the Z80 can. The other I/O expander right here is used to allow the Arduino access to the controller ports. So basically, if this chip is activated, then the control ports are going to the Z80, and if it's not activated, the control ports are going to the Arduino for you know, menu selection and whatnot. So down here we have the 3/8 mux, the OR, and the NAND. This is used for device selection and also the clock tricks that I use to, you know, basically I drive the Z80 with a timer from the Arduino, but then the Z80 can also disable its own timer. That's how it does the port access. So 3/8 mux, OR, and NAND. Keep in mind, all of the chips in the bottom side of the board, they're all in the same orientation. So pin 1 is always on the right-hand side. And over here, the chips are all going in this direction. So pin 1 is on the left-hand side. And a cat has appeared. How'd you get in here? And when you're soldering these, make sure you don't bridge any of the solder into the vias. It's a pretty tight design and it's only 2 layers, so yeah, there are a decent number of vias. All right, that should be pretty good. Again, flux isn't super conductive, but it's also not non-conductive, so clean up as much as you can. All right, let's install some tack switches next. So here's a tack switch. Okay, so for the tack switches, here's what I'd suggest. Same thing, just start with one of the legs. Get like a good top-down view of it with your brain and your face muscles. Just heat up one pad and then bring the switch into it. This one's a little tricky because apparently I've soldered this pad already for some reason. Yep, then once you get one, then you can just do the rest. One thing, this is the reset for the Arduino, for the Atmel chip. And you might want to actually cut this switch down a little bit because as is, it might be a little proud of the SD card. And I mean that in like a construction sense. I mean, it's going to stick out a little bit. The SD card slot goes in like this. So if you want, maybe just give it a little bit of a nip like that. That way it won't accidentally press with all this is in place, okay? There should also be a jumper and a couple right angle connectors. So this one's important. This is the clock jumper. So the 6 megahertz clock, or whatever you want the frequency to be, is actually generated by a timer on the Atmel. And so that timer goes through this jumper and then it goes into the Z80 and of course the timer interrupt circuitry that I talked about. The reason I have a jumper here is so if you want to provide an external clock, you could basically just take off the jumper and then attach your external clock here. Well, check the schematic, but that's why there's a jumper here. I designed this thing like 6 months ago. I forgot most of it. The other jumper, put it right here. And that's just a place you could hook up external power if you don't want to power it over the USB port. Oh, I realized there's a capacitor right there. I probably should have. There's a capacitor right there. I probably should have put that in first. Oh well. Okay, then we got electrolytic capacitor. Note the plus is on the right hand side. So you want the long wire to go into the right hand side and the stripe to be on the left, which is ground. Then what I like to do with these is just give them a little bit of a bend just to hold it in place. Then solder it and nip it. If you bend it too much, you might not get as clean of a nip. There's going to be 3 indicator LEDs, on status, and then TX, RX. So they're all oriented the same way. The positive anode lead is on the left, negative on the right. You'll note these copper strips at the top and the bottom. Say your unit might already have this, but just give it a good solder flood like that. Oh yeah. You'll see why in just a second. I'm sure some of you have already figured it out. Flood that baby. And you do that so you have a good place to clamp your testing equipment for multimeter and oscilloscope ground reference. Look at that. That's also where you can attach your, if you want to wear this as a badge, you can attach your lanyard right there. So you need like the lanyard with the clip on both ends. The reason I did that was so unlike every other badge, this wouldn't flip around backwards. So every time there's a badge that only has one point of contact, like 90% of the time it's backwards, even though it should be 50% of the time. So simulated universe, you decide. Okay, so here's the switch that you cannot find anymore. The reason I used it with this project was because I had a bunch of these and I was just trying to use them up. But then when this became more of an online only thing, that does disadvantage people. But you know, this is on my GitHub, so you know what, just download the file and then change it to use a modern, I mean, you can still get switches like this, just not this model. You know, just use a modern surface mount version of it. Because basically I was like, well, I have like 25 of these, so I'll just burn up 20 of them. Because otherwise I was never going to use them. So right there, that is the resistor array. It pulls up the joystick line. So see how there's a cross? Kind of hard to see on the left. That's the common line. So you'll notice there's going to be a dot and text on the resistor array. There's the dot right there. That goes to the left. So this resistor array, it kind of looks old and chunky, but it actually takes up less space than the surface mount resistors would. And that was actually my first thought, was like, oh, I'll just use surface mount resistors for this, but this actually takes up less space and is easier to install. And it kind of looks cool. I mean, you don't really used to see these all the time in like game consoles, but well, again, if you were to buy a modern resistor array, it would be a really tiny part. Yeah, there's one here on this pinball machine. Yeah, see that little guy there? That's the modern alternative. And as you can see, it's not much bigger than the tip of my pen. There's a header here. It's not really critical, but this will allow you to hook up an external keyboard. If you have like a serial keyboard that outputs like 115200 baud, you detach it here so it's signal and ground on the bottom. Looking at this now, I should have installed this before the clock jumper. Oh well. 0.1 UF capacitors. So I've got 3 different examples here because it's one of those things where it's like, oh man, I've got tons of these. You know, I don't need to order a special batch just for the workshop. So point being, you're going to get random capacitors. So that one was pretty straightforward. This one's kind of got like a, I don't know, bow-legged. It's got like a bow-legged thing going on. So let's put that guy here. Come on. So yeah, you might have to bend those pins a little differently. The reason that the capacitors are through holes, I just wanted to make it a little easier for the workshop. So, you know, all the resistors are surface mount and the capacitors are through hole, basically to differentiate them. Although surface mount capacitors would have been a lot more elegant in this case, but they'll work. Got to be careful around this one right here. It's really close to the microcontroller, so again, I probably should have installed the capacitor before I installed the jumper. All right, I think that just leaves the screen and the Z80. So make sure you notice where pin 1 is, and there's a notch on the socket. See the notch on the socket right there, the notch on the chip. Yeah, it'll come taped in the right position. So in this one, yeah, I would just flip it over, press it against your work surface, same thing. Hit the 2 corners, and then hit the whole thing. Oh, you want to watch me do it because it'll be pleasurable? Fine. Let us go out this evening for pleasure. The night is still young. Die, monster! You don't belong here. It is not by my wish that I am once again given flesh, but rather humans who wish to pay me tribute. Tribute? You steal men's souls and make them your slaves. The same could be said of all religions. What is a man? A pitiful little pile of secrets. But enough talk. Have at you! Wait, I think I missed one there. The world has ill need of a savior such as you. Do-do-do, do-do-do, do-do-do-do-do-do. Dun 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 dun. Dun dun dun. Dun 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 la dun 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 la dun 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 dun. Little OLED screen. You can peel off the plastic if. Well, you should peel off the plastic. I hate when people don't. It's like, I've had this VCR for 25 years and I never pulled the plastic off of the display. You can socket this if you want, but if you leave it flat, it makes it easier to get at these buttons here. So same thing, I'm just gonna hold it parallel and, well, there's only 4 connections, so it's not like this would be hard to remove. All right, got the screen installed, finally. Oh, I need to dig up an SD card. I'm not shipping SD cards with these because when MGC got canceled, I stopped buying parts and the SD card was the last thing I was gonna order, so you have to provide your own, sorry about that. Oh, I'm not sorry. Who am I kidding? I was like, just take a little piece of double-sided tape, put it over these expanders here, and then I'm not going to insert the card yet. But yeah, just a little bit of double-sided tape will hold that flat, or it's supposed to. Oh, these pins are, yeah. Oh, there. The pins were off a little bit. There we go. So I've run out of through-hole 0.1 UF capacitors to include. This is kind of embarrassing. So if you see a strip of things like this in your kit, these are the surface mount 0.1 UF capacitors. And here's how you can make them work, even though it's meant for through-hole. Again, I don't know, if you're into electronics, you should have 0.1 UFs laying around, but if you don't, you can use the surface mount ones that I've included. Yeah, just, you can kind of do it like a surface mount. So just do one pad and then the other. Sorry about that. Okay, assuming I did everything correctly, it's time to hook this up to a computer. All right, so let's try this out. I'm going to plug it into my computer using a mini USB cable because that's my favorite. All right, let's go into Device Manager. We should see this pop up as something. Okay, we got the Windows connection noise. All right, and then yeah, we can see an Arduino Leonardo on our, I'm gonna use Arduino 1.6.9. All right, so this is the latest version of the code off GitHub, Z80 Note Interface 04. We're gonna go to Tools, make sure we have the Arduino Leonardo port. Looks like this is on COM3. So we'll select that and then we'll upload the code. All right, and now we have the message, insert SD card and reboot. Cool. All right, so I'm going to turn it off and make the SD card. All right, I have a freshly formatted micro SD card here. I called it Z80 Note. I'm going to take the basic bin file from the GitHub, put it onto the SD card, and install it into the Z80 Note. Click it in place. And now we should get, all right, cool, we're up. Basic help. So remember, it won't boot correctly without an SD card in. All right, so it's going to show us all the files and the size of each file on the SD card. Obviously, there's only one right now. It's probably a little hard to read. So I'm going to hit A to select basic. It's going to load it, and boom, there's our prompt. Let's do this. Over here on my computer, I'm going to go into PuTTY, which is a terminal program. And I've got a setting here for the Z80. I'm going to load it in. So it's COM7, or you'll have to check what COM port it is. It should match whatever the Arduino program had. Speed 115200, that's not super important. On terminal, we want to say backspace key is Control H because that's actually what this thing is going to expect. All right, we can open it up and it's waiting for the enter key for the memory top. So if you don't type in memory top, it just scans and sees how much RAM you have. So there we go, 56 kbytes, which makes sense because the bottom 8K is basic itself. All right, so basically the little screen on the unit is just going to duplicate everything that we type into it. So print hello world, exclamation mark, 19, go to 10, boom. All right, and then we hit Control C to stop it. So one of the cool things I put into the menu is the ability to not have to use the keyboard. So if we hit the menu button here, we go left to basic help, and then we can run it right from there. See? Then we can also break. Then we can list. Oh, hit break twice. Yeah, so that makes it pretty handy. So what you can do is if you use this as a badge, you can basically load the programs and start them without having to use a keyboard. Yeah, that's why you've got, that's warm start plus run. Actually, let's just go back into, so like if we reset the CPU, it's going to give us that prompt again. So we're going to go warm start plus run. And since the RAM wasn't erased, it goes right back to the program that was in there before. All right, let's just take a quick look at some other stuff here. All right, so this is going to be, the programs you can load or the bin files you can load. RAM dumper will allow you to dump the contents of your RAM to SD cards so you can make a copy of your work. So for instance, you could write a basic program, dump it to RAM. So for instance, you could write a basic program, dump it to SD card, and then load up the entire 64K image, then run it directly from here. Like if you wanted to program a game without having to use the external keyboard. And there's going to be some settings that'll be stored to the EEPROM. RAM viewer lets you view sections of RAM. CPU control, you're going to be able to single step. See, it's running right now. That stuff's moving, but should also be able to adjust the speed here. Again, the code's not completely done, but this will at least get you started. And then when you want to go back, you just push the button. Of course, it's stopped right now, so I can type into my computer as well. List. All right. We can do something a little bit more complicated. Let's do this. A equals random 1 times 10. That's a random number from 0 to 10. For G equals 0 to A, print a space, next G, print hello world, hello world, and then go to 10. That'll give us a randomized hello world. Then we could also go in here for G equals 1 to 100. Next G, basically just to create a delay. Nice. All right, when I get the code a little farther along, I'll show you how the RAM dumping works, but this should get you started with the kit version of it, at least for now. And if you have trouble getting it to load, here, let me see if I can. All right, so break. So I could actually go into the menu and reload everything. And sometimes it works, sometimes it doesn't. So you can just try it again. So I could just go in and load it again if I wanted. And then if all else fails, you can hit reset. And well, that's going to reset the Z80 itself. It just gives you the same message, cold or warm start. So remember, the RAM hasn't changed. So if I hit warm start plus run, it's going to go right back to the same program. So remember, resetting the CPU does not erase the RAM. All right, well, that's how to assemble the Z80 Note kit as it will be mailed to you, which is different from building it from the ground up. Yeah, just make sure that you don't bridge any vias. You use your magnifying glass to identify the NOR and the AND correctly. And yeah, just good luck, and hope you have fun with it. Obviously, I have more to do with the code. I was, had MGC taken place, I would have crunched and finished the code back in March, but then of course everything got delayed, so I moved on to other projects. So the code's still a work in progress. Yeah, I was rewriting parts of it, improving the RAM dumper, because basically you have the Atmel doing RAM access, and there's a few things you have to take care of. But yeah, the basic, the idea is you'll be able to basically fill the RAM up completely. So if you wanted to make like a CPM system, you could actually have it, you could put the CPM boot at, the reset vector of 0000, and then you could replace it as needed. And there's actually one of the lines here on the card edge connector will actually disable this RAM, which would allow you to add external RAM as well. So everything should be down here for your use. All right, well, let me know what you think in the comments below. And again, this is a work in progress, but this video was basically just to show you how to get started. And do note that you saw me flash the code over to this. When we pre-assembled these, we just flashed the bootloader, which allows the Arduino to be programmed. We did not flash on the code to make it run. The reason we didn't do that is because if you try to run the entire code without all the chips installed, it will get hung up, and then you actually might not be able to use the bootloader at all. So make sure you install everything before you flash the code.